So first of all, welcome to Wisk. This is something we have never done for anybody outside of the employees. In fact, many of the employees haven't even seen these aircraft.
They literally let us behind the curtain to see a test flight of what will autonomously fly 4 passengers from existing general aviation infrastructure in busy airspace. And this is the first ever candidate for FAA certification of an autonomous eVTOL aircraft. So I'm proud to be here representing the general aviation community to ask some hard questions and check this thing out.
There's a moment before, right now, and the moment after. So, would you like to see the moment after? That's the veil.
FlightChops has been replaced by a triple redundant algorithmic artificial intelligence, which is generating the content for this video.
This video will be made by a human, but this aircraft will not be flown by one. So they left me alone with it. Think I can steal it? No. No, I cannot. There are no controls on board. This is the first time I've ever sat in the front seat of an aircraft that has not got any controls. So how'd I get here? Well, I've been doing this FlightChops thing for almost a decade.
Congratulations, Steve Chops. You passed your rescue swimmer survival qualification today.
And that's allowed me to capture and share contact! Some amazing flying opportunities, including this invitation to visit Wisk in Silicon Valley.
Secret black bus today.
The team here is highly engaged in general aviation, and several of them are existing FlightChops fans. It's pretty cool that you already knew the channel. That's exciting.
Yeah, it's unmissable, really. It's unmissable.
I'm stuck with this goofy mustache as my brand. But in all seriousness, I was honored to be invited to this event to represent the general aviation community and ask whatever questions I wanted. And I asked some hard ones, like how is redundancy built into this thing to be safe for passengers? How will it fit into the existing ATC infrastructure? And so on. There's a bittersweet thing here about the idea of the pilot is getting kicked out, but it's also opening up a whole new world. I mean, you want to speak to what that means for GA?
Yeah, absolutely. I'm part of the GA community myself. I'm an instrument-rated private pilot. I love flying, and I don't see this as taking away from that at all. This is only going to add to the opportunities people have to get to the sky.
I was impressed with how forthcoming they were.
If you want to raise your hand, either Chris or myself will come over and give you the microphone. Steve?
I guess as a pilot, I have a zillion questions, but I'm going to try to minimize them. On top of my Q&A questions, I got one-on-one access to key team members, including test pilot Mike, to talk through the flight.
You know, we could have up to 8 people in the control room stations, but the minimum crew really would be a pilot and test director if we wanted to.
This is like everything could happen from this station right here?
Yes, everything can happen from this station with a pilot. There are no conventional controls like in general aviation airplane in this.
And then as a pilot, are you excited to ride on one of these things?
I'm super excited, yeah. I mean, someone asked me, would I be worried, as a pilot, would it feel weird to be in the cockpit and not have the control of like being able to control the airplane? And I would say it's a two-sided coin, right? Because yeah, some people want the control, but also as a pilot who has real world experience, I know firsthand some of the challenges that pilots have and some of the you know, frankly, some of the interactions that are kind of generate a pucker factor when you're flying out there, right?
Okay, well, it's good to meet you.
Yes, you as well.
I'm proud to be here, and I mean, this is what FlightChops has opened up these kind of opportunities for me, but I'd love to know that you're watching the content.
Yeah, I think one of my favorites of yours was you showing how close you can get to a ground loop. I can't remember what you were flying.
I was probably flying the Super Cub, but I showed it in the Stearman like that.
That's, yeah. That was it.
All right, let's see this thing fly, and then we'll get back to Dan and the rest of the team for more details. So we are 2 minutes away from seeing this thing fly. Pretty cool.
Do they know where they want to go?
We're in the control room. How busy was this during the test flight?
It was not too busy. We had 4 people in the control room. So you have a pilot station, test director, and then 2 engineers. So what you see here is the pilot display I would have been using today. We've got all of our pre-flight checks done. We are at our takeoff location. We've completed motor arming, which has the vehicle in a state where that all it needs to be done is click liftoff. Plenty of energy. Battery temperatures are good. Everything's healthy. No CAS or AHMS messages telling me we got problems. Get the liftoff call from outside. Select liftoff. Got accepted. We look up and say, okay, we're in pre-flight mode. That'll tell me that the airplane's checking its systems. And if the vertical propulsion system's healthy, it's going to go spool up.
And this is obviously simulation right now.
Simulation, but exactly what I was seeing. Yeah, I didn't click the airplane.
The airplane didn't just fire up out there.
The airplane did not just fire up out there.
But because this sim is so precise, it will sync and intercut with the actual flight we just seen. So let's do that to illustrate.
So we are in spool up mode and we should be seeing it lift off shortly. So we're airborne now, climbing up to 33 feet for this particular flight plan. Again, it's all automated. I can intervene if necessary, tell the aircraft to land. It projects a point in front of it as it has to decelerate, and then it will land at that point it projects. We have all these on test cards that show us all the contingencies. So here we're accelerating. We'll get to our magic speed of about 82 knots. It's be fully wing-borne. All the fans are stowed at that point, so we're completely on the wing. And just the forward propulsion system is telling us that it's running a little less than half power right now. On the wing, it's a fraction of what the vertical propulsion system is. So here we are, cruising along about 83 knots, and we'll be coming to decelerate here shortly. I see the commands starting to come on. Fans, okay, forward propulsion's coming back. Your vertical system will now come on as it scales back in airspeed. See, it's on, still tracking altitude pretty good. And it will decelerate here. As it decelerates, the vertical propulsion system will be taking over for the wing since we're not in wing-borne flights. Do a pedal turn. It's using, as you can see here, it's turning right 180 degrees. It's using the fan torque and it's compensating with the fans to give that torque for the right turn. Now we're continuing back out on the forward propulsion, and then the vertical system will scale down as we increase in airspeed back to wing-borne flight. So there's two transitions in this particular flight that you see.
And then I guess the question a lot of pilots are going to ask is like, to get a clearance to fly across SoCal currently is a pretty arduous process. How is it going to work? You guys are talking about integrating into the system. You're working with the FAA.
All of our flight plans are preloaded onto the aircraft, and it's basically the multi-vehicle supervisor on the ground that is selecting, accepting, and ultimately executing those flight plans. So they are working with ATC on the fly to implement those flight plans, and they get the clearance and they go, and it's flying that predefined route. They are only going to intervene if there's a problem along the way. So they can choose to go back, they can choose to complete the flight as filed, or they can go to an alternate if there's an issue en route.
So we're talking about VFR, IFR, and I'm hearing talk of DFR.
Digital flight rules, I should talk to that.
Yuri couldn't talk about that yet as it wasn't announced as of this shoot, but Brian from Boeing kind of spilled the beans here, which was okay because we were all under embargo at this point.
That will enable us to lead in the next century of flight, which we think is going to be all about sustainability and ultimately autonomous operations. I should mention that tomorrow we're going to be releasing...
Wait. Everybody's under embargo, so we need to talk about... This is another little sneak reveal.
Yeah.
Go ahead.
Should we mention tomorrow? Yeah, this is still under embargo, right? Yeah.
Yeah.
Okay, cool. I assume everything I'm saying is under embargo, so yeah.
No. Don't make the assumption.
The password to my bank account is...
so let me tee it up, and then,
go ahead.
Then you talk about it. So we have been working for years with Boeing on creating a concept of operations, so a Conops, and we're going to publish that tomorrow. And that's something that we've been working with the FAA. This is like, putting meat to the bone, if you will, fleshing out exactly, when I talked earlier about a system, this has to be a system that all works, in tandem together. We're going to publish our concept of operations on how all that works.
Yeah, and the important thing to us and to the combined teams here is that it's not just simply saying, we're going to make a self-flying airplane and, here's how you get into it and out of it and so on. It is deep thought about functional automation. Who are the actors in the system? Because there's new language that has to be created. You'll notice that Becky and the team have been using this term multi-vehicle supervisor. That's extremely important. That's an actor in the system. They have specific responsibilities. They talk to specific other actors in the system. All of those definitions have to get created.
And back to the second half of the demo flight in the Gen 5 aircraft, it's important to point out that in Gen 6, they've refined the propulsion system and removed the pusher prop from the tail.
Come up to 82 knots, the fans have stowed again, and we're on the wing. If I needed to, could abort, could stop the flight. There's different contingencies depending on the flight plan we have. If I zoom out here, you can see the projected landing points, or the final landing point. Zoom back in. This port, it transitions over the grass. We get our altitude estimate from numerous sources, both GPS and the above ground sensing that we have on the vehicle. And it's going to make its way over the pavement to our projected landing location. Everything still looks good. If we had any contingencies, we said we have the aborts. We also have the box if we need to. We're too low for the ballistic chutes. There it is to our small confined pad where it took off from. It's going to enter its hover, and we're in the hover state according to that at 33 feet. It'll stabilize. Now the timer's set and it's going to start descending. So there we are. And we'll get AGL. So we got 2 ground sensors. It says it's in touchdown mode. Spooling down, and then our flight's complete. We'll do a post-landing check or checklist with the crew chief in conjunction outside, shut the high voltage off the aircraft, and then we'll remove it from its landing location for its next sortie.
So that's all well and good for a test flight in controlled conditions with no external variables such as traffic or ATC to deal with. But I was keen to explore how they were going to make this work in the real world. And then you are working with the FAA to get it certified.
Yes, we are.
So that's pretty exciting.
It's exciting. It's not, I mean, what we're doing from a self-flying perspective is obviously not the easy path. And this is a system that we've got to get certified. You know, 93% of aviation today is automated, controls are automated. And sure, we're doing that final 7%, but we're also going to try to take advantage of GA airports. You'll see a lot of CGI videos that have cool new vertiports, and it looks like, oh, this is going to be great, you know, Jetsons kind of stuff. But we're a lot more pragmatic. There are a lot of helipads that are unused. There are a lot of GA airports that have capacity, and so we're going to look to leverage existing infrastructure instead of building it new. It is a system that we're going to get certified.
So with that in mind, I guess the whole IFR, VFR, DFR, or do you want to kind of address what?
Well, we're by definition, we're IFR, and so we're going to be able to fly in most conditions. A lot of the other folks that are introducing air taxis in this market won't be, they'll be VFR, and so they'll have a much more limited window in terms of when they can fly, but we're going for it. We're going for IFR.
With each of the generations of aircraft, we've always kind of seen, I think, many of these as proofs of concept, whether it's the battery technology, the vertical lift technology, even the composites. So now that we've kind of had these 5 generations of aircraft, it's a matter of, okay, now with all of the technology demonstrated, let's put on our certification hat and really look at designing this aircraft with certification in mind from the beginning. And so it's given us the opportunity to really pull in all these technologies through a certification lens and then bring that to the FAA to be able to say, okay, here's our decade plus of testing, and this is why we feel comfortable having this autonomous system with these various battery technologies, et cetera, et cetera. So yeah, so we've been talking to the FAA for quite a while. Actually, in fact, every 2 weeks we meet with them on something, and so I've been doing that for years.
So can you get specific about like Ripple redundancy or any of those type of terms that people like?
Yeah, DAL-A, Design Assurance Level A, or 10 to the minus 9, is kind of the way that we're targeting this system. And that really means that it's designed to have as much redundancy as you would see in maybe a Part 25 aircraft, like a transport category aircraft. And so we think that with that high bar, that high level of safety, that this will make it that much easier not only for regulators to understand and to be able to pull into their certification structures, but also for passengers to understand, oh, this is as safe as one of those aircraft.
So what you're seeing here is a simulation demonstrating how our autonomous aircraft might navigate the airspace environment, including restricted airspace in Honolulu, Hawaii. As you've seen, we've already proven that we can fly autonomously with our existing aircraft. We need a way to safely integrate these air taxi services into the national airspace system. And we're also working closely with a subsidiary from Boeing in situ for detect and avoid technologies. What you're seeing in this video is an example of some enhanced detection capabilities between an autonomous aircraft and other airspace users through onboard sensing capabilities. So this technology is designed to advance the ability to integrate autonomous aircraft into the different classes of airspace. As seeing and avoiding aircraft, as you may know, is a critical function required to operate in the national airspace system. In many of these encounters, by the way, the system was able to detect the other traffic before the human pilot even had a chance to. So that demonstrates some of the potential that these technologies have for increasing safety.
The other thing that I think is super exciting for pilots is a lot of the technologies that we're developing, like for instance, technologies around detecting and avoiding other aircraft will be used in general aviation aircraft too. So, it's really hard to see other airplanes. The technologies that we're developing for this aircraft, you can put on a general aviation aircraft, and it can be assistive. It can tell you where to look in the sky so you can fly safely.
But so is DFR a thing? Do you want to talk about that, or digital flight?
I mean, it's not today. There's a lot of conversation. So we work really closely with NASA, especially on this concept, and looking to see how NASA, together with the FAA, can build out that for the future. I think what it's going to take is a lot of conversations and a lot of demonstrations, frankly, of aircraft like ours to be able to show that this can be done safely and securely in and among other airspace users, to make sure that not only can we operate, in a city in a Class Bravo under a Mode C veil where there's a lot of surveillance, but also being able to have operations out in the rural areas where you're not even legally required to have a battery, let alone an ADS-B out. And so how we make sure that we can, that next phase of integrating with that type of, environment, so we can fly in and among the Stearmans of the world, that'll be the next tranche of things. But for now, we're starting with, IFR, so to speak, with an asterisk. And I think that's just going to take time to show that we have the data to actually justify the changing or the addition of that rule set.
And so knowing all the information that the system has access to, that I literally can't process all that information in real time as a pilot, means that there are some dicey situations you can encounter in your piloting career, right? I think any pilot can relate to that. And I think the fact that we can imagine, consider all those scenarios from the outset, right? And being able to program the right response in and not responding is my gut instinct to recall the right procedure going to be correct today? It is going to do the right thing, and all the engineering that we put into it is going to be a part of that decision. So that gives me, as a pilot and an engineer, confidence flying on something like this, certainly.
So we're quieter. Our noise signature is not a wop-wop. It's more on the white noise spectrum, so we blend out. I mean, in cruise, you won't hear us. But there's another aspect, right? And that is, we're targeting to bring this service to be very competitive with existing means of transportation. That doesn't exist today in aviation.
If anything, we're competing with the Ubers of the world, right? Something that's going to get you from near your house to an airport, not something that you're going to take from a city to city.
And so if you're able to bring the operating costs down of these aircraft, now the incentive for bring this infrastructure to society changes.
We really see this as kind of opening up the aperture of aviation. So many of us, so myself, GA pilot, love flying, love being in and around airports and the whole bit. And we see this as being able to bring new folks, new entrants to that.
I see this as, yes, it's providing this new transportation means that won't have onboard pilots, but will have ground observers. But it's going to make flying safer for all of us.
And we're not taking a mission away from any existing form of travel. There's nothing that does a 15 or 20 minute hop for your commute right now. This is only adding to the variety of options people have to get around.
This isn't displacing, there's still going to be the need for traditional pilots in other categories. Do you want to speak to that? This is opening up a new category as opposed to offset, you know what I'm saying?
Right, yeah. Helicopter pilots, GA pilots, none of that's going away. The scale at which we're looking to operate these things would only mean more pilots are needed. Even with a multi-vehicle supervisor supervising 3 or even 10 flights from the ground, we're still going to need more pilots than are available today. A lot of what we're doing is working on the training that would take to make that fleet of people, operators on the ground available to us.
Steve, did we get it?
You can answer glide. I don't know.
Talk about glide. Every pilot is going to ask that question. Sorry, what?
Will it glide?
Yes. It can glide, yeah.
It's fixed wing.
Yeah. Okay, well, that's cool. I tried really hard to get all the details into this video, but there was a lot that we covered. But it does seem these guys had answers to all the hard questions. In terms of the triple redundancy, there's dissimilar software and dissimilar processors. It's EMI protected from lightning, solar flares, and even EMPs. I'm actually going to share a raw version of the presentation for Patreon supporters, because that alone Jim went into a great level of detail on that I just couldn't fit into this one. But this is definitely a pretty cool time in aviation. I still love flying warbirds, but I definitely also like geeking out on high-tech stuff. So until next time, keep your flight chops sharp.
There's a red phone. Yes, there is a red phone, and it's our emergency phone, our bat phone we call it. It's funny, we have a red stapler too.
Oh, okay.
So I know.